Hello, my name is Daniel Fraser, and this is Crash Bandicube. This was an individual project meant to demonstrate knowledge of an NPC gameplay scenario in an AI class at Sheridan College. This project was built in Unity and makes use of Voxel, Photoshop, and Behavior Designer. As the solo developer, my focus was designing, programming, and putting together the visuals using free and self-made assets. The idea was to design something novel on top of the NPC requirements. I wanted to make a boss scenario built around the theme of an existing platformer, Crash Bandicube. The character must move, jump, spin into enemies, and attack the boss computer screen to win the scenario. The AI boss behavior was designed using finite state machines in Behavior Designer. Boss will cycle through stages of idling, attacking, and resting, with nested states at the attacking and resting stages, providing a level of depth to the battle. The room itself was designed with specific space in mind. It's a simple flat grid with no other objects to get in the way, and some attacks will line up with the tiling so the player can more easily read what areas will be safe or unsafe. This setup is similar to other boss fights found in the Crash Bandicoot games, such as Ripperoo's fight in Crash 2, where TNT or Nitro are placed directly on tiles' centers. The attacks themselves were inspired from some other boss fights as well. Sweeping motions were inspired by the Entropy fight in Crash Bandicoot Warped, while some other ones such as the Spread Rockets were inspired by N-Jin's attacks in Crash 2. 3 sets of attacks seemed like an appropriate amount of time for the boss fight. Again, similar to fights found in the Crash series. Players will have time to attack after a given set of attacks have completed. If the player messes up their timing by the end of the 3 sets, the cycle will repeat. Another neat addition to the project was adding minion enemies, as they made use of the NavMesh navigation tools found in Unity and have their own finite state machine. The hardest problem I solved was making attacking sets functional in the finite state machine. It was sometimes difficult to nest attacking stages properly in the engine, moving from one attack to the next. In addition, returning to the right attacking set after a rest period was buggy, as attacking sets would repeat instead of moving to the next one. Eventually, setting up proper triggers for what stage was to go next in a sequence allowed for the returning from rest to return to the correct next set every time. After a lot of debugging, sets now worked without the system sequencing improperly. The system was now built for modularity, easily allowing attacks and their sets to be added without any additional friction, which came in handy when one of the sets had to be reduced from 3 attacks to just the minion launching due to time constraints. Making a tightly designed boss battle was not only enjoyable, but rewarding. It was a neat exercise in testing my design knowledge on a smaller scale, and also my programming skill for simple AI systems and completing entire game loops with a little bit of polish. It was fun. Thank you for watching this breakdown of Crash Bandicoot.